can't get rid of that. All right, let's start with going over some of these proofs together. And then we're going to be doing a new lesson today. All right, so we talked about proofs that, and again, this is back from 3.2. So we're starting with parallel lines and we're proving things about the angles in the parallel lines with the parallel lines. So for number 2, okay, they've given you the statements on this one, so we're just filling in the reasons. So first of all, the given was the H and G are parallel. When they give you information, you should mark it on the picture, okay? They told you the measure of angle 1 is 50 degrees. Please make corrections on this homework and you're going to resubmit it. So I want to make sure you have correct proofs. Okay, what is the reason that angle 1 is congruent to angle 2? What is the reason for the second step? Jake? If lines are parallel, then corresponding angles are congruent. Okay, so that means we know that angle 1 and angle 2 are congruent. All right, step 3 says a measure of angle 1 equals the measure of angle 2. Lily, what is that when you go from the angles are congruent to the measures are equal? Yep, that's what that is, definition of congruence. And you can say congruence or congruent angles. Okay. And then measure of angle 2 equals 50. Braden, what do you think that is? Okay. Could you call it transitive also? Yes. So you can say it's substitution because you say, okay, if these are equal, I'm going to go ahead and plug this in place of 50 in place of the measure of angle 1, and then I'll have measure of angle 2 equals 50. Or you can say it's transitive because if, let's go, if measure of angle 2 equals the measure of angle 1, and the measure of angle 1 equals 50, then the measure of angle 2 equals 50. So you can call that transitive or you can call that substitution. And just like always, you don't have to write both, but I would accept either answer. Okay, questions on that one? All right, for the second one, we have M and N are parallel, and angle 1 congruent to angle 2, angle 1 congruent to angle 3, so therefore angle 2 is congruent to angle 3. This is given. Without even knowing what steps 2 and 3 are, you should be able to tell me what step 4 is. What is the reason for step 4 by looking at those statements? Somebody says Jake has to talk to me. What's the reason for step 4? Okay. Oh, deep blur, you know. What is it? Okay, that's actually what you're proving. You can't use that as a reason because that's what you're trying to explain why it's true. So rather than looking at the picture, I literally just want you to look at the steps before it. We should be able to know what the reason for step 4 is. Kara, was that what you were going to say? Or, okay, go ahead. That's transitive, all right? So it's a little bit tricky because you're actually proving a theorem on this problem. That honestly doesn't usually happen, but this is a theorem that you're proving. So you can't use that as a reason. You're trying to get there from other ways, okay? 1 and 2 are corresponding, okay? 1 and 3 are vertical. Therefore, 2 and 3 are congruent because of transitive. Braden. Okay, so for number 4, could it be substitution? Max, could number 4 be substitution? Braden, if you write substitution, property of what? Okay, there is no substitution property of congruence. It doesn't exist. So no, that cannot be substitution. If it's congruence and it looks like substitution, it has to be transitive. Okay, substitution is only for equations. So transitive is a property of equality and a property of congruence, but substitution is only a property of equality. All right, so you got to make sure you call that transitive. With these problems, a lot of times your last step is, with these proofs, a lot of times your last step is going to be either transitive or substitution. So just pay attention to whether it's one that you're using congruence where it's transitive, or whether it's one where you're like plugging things into equations where it'll be substitution. Okay, and then we also didn't do this one down here in the corner. When you're making corrections, you should be leaving what you had there before and just putting something, like putting the right answer beside it. That way, when you look at it later, you'll know what you thought initially that was wrong, so you can try to get that corrected in your head. Okay, so this one said L and M are parallel, and we were given an angle 1 and angle 4 are congruent. And we're trying to prove that 3 and 4 are congruent. So when you look at, there's literally only one step between them. When you look at angle 1 congruent to angle 4, and then angle 3 congruent to angle 4, that should tell you what step 2 should say. What should step 2 say? Somebody has not talked to me today. Okay. Okay, so how do you know that it should be angle 1 congruent to angle 3? I'm not even talking about from the picture. I'm just talking about from steps 1 and 2. Is what? Okay, but why did you pick 1 and 3, for example, rather than like 2 and 3? Because 2 and 3 would be congruent also. How did you know to use 1 and 3? You should know that from looking at the statement. So I don't know if you're looking at the picture right now. Why does it make sense that step 2 would be angle 1 congruent to angle 3? Okay, you know that 1 and 4 are congruent. You're trying to get 3 and 4 congruent. Well, it's not substitution because that's what we just talked about with Braden, but it's transitive. So if you have angle 1 and 4, we want to keep 4 there, right? Basically want to swap out angle 1 for angle 3 for angle 1. So that's like our connector. So again, with these problems, very often it'll be 3 or 4 steps and it's transitive. You just have to figure out how to get it to work together. Okay, so when you're looking at these, you want to notice that from here to here, we have angle 4 we're trying to keep. So that's good where it is. And we're just trying to replace angle 1 with angle 3. All right, so your reason of if lines are parallel, then corresponding angles are congruent is correct. Okay, and your last step will be transitive. And again, that should not be substitution because substitution is not a property of congruence. It does not exist. So both of those two proofs were transitive. When they're equations, on this one, we could use either. Excuse me, we could use either. But with the congruence, it has to be transitive. Okay, we'll have more practice on these. Tonight's homework has 2 of those kind of proofs, and then the quiz review will also have some proofs. So you'll get more practice with that. But do you have any questions on this first page? Anything that you want me to explain again or clear up? Okay, so for the second page, let's see, we did this one, right? And then we did this one, and then we did this one. Am I right? I think we did those 2. Okay. Oh, let me write this the way that we write it. I write it differently with honors than I do with you guys, so sometimes you'll see me writing it in a different way. If lines are parallel, then alternate interior angles are congruent. So x is 10. That's the value that will make that will make those angles congruent, which they have to be because the lines are parallel. Now, for these problems, you should be writing a statement. That's what I mean. Writing a statement is this. Okay, so linear pairs supplementary, vertical angles are what? Vertical angles are what? Congruent. And then all of the, if lines are parallel, then such and such and such, okay? All of those things are things you can be writing there. So, but that is part of your answer. So you need to make sure you're writing those statements. Questions on the first one? Diamond, will you sit up, please? We didn't do this, so don't need that. Brady. Oh, I'm sorry, I skipped over it. Let me go back up to the top. There we go. Sorry about that. Do you agree with my answers? It's a little hard to read those stuff like that. Okay. For this one. So remember that we talked about how you want to use the parallel lines in one transversal at a time. So just look at the left side of the picture and use the left transversal. How are those two angles related? Okay, they'll both be 90 degrees. What are they in terms of like alternate interior and that kind of stuff? They're what? They're consecutive interior. Grant, how are consecutive interior angles measures related when the lines are parallel? Consecutive interior angles, how are their measures related when the lines are parallel? That means, how are those angle measures related? Okay, in general, how are they related? Like if this wasn't 90, if that was like 70 or something, this would be 70? They should be, Michael, they should be supplementary. So if that was 70, this one would have to be 110. Okay, so your theorem for that one is if lines are parallel, then consecutive interior angles are supplementary. And that makes 3y plus 18 have to equal 90. It's the same thing on this one. Okay, we have parallel lines and one transversal. Those are consecutive interior, so they have to be supplementary. Let me fix this also. We'll just say if lines are parallel, then consecutive interior angles are supplementary. Questions about the solving of the equations or anything on that one? So do these two angles have to be supplementary? Will that angle and that angle be supplementary? Is it a yes or a no? Okay, how are they related in terms of like corresponding and that kind of stuff? Michael? Okay, they're also consecutive interior. Are these lines parallel? No, that means that they will not be supplementary. The only way that the consecutive interior angles are supplementary is if the lines are parallel. So if we actually went back through and plugged in the values of x and y, we'd be able to tell. So like, for example, put in x equals 6, that would make this one 60. 3 times 24 is 72, I think. Yeah. 72 plus 18 is 90. Yeah, actually, we knew that was 90, didn't we? So those will not be supplementary, right? Because these lines are not parallel. Consecutive interior angles are only supplementary if the lines are parallel. Same thing with the congruence, like the corresponding angles are only congruent if the lines are parallel. If you don't have parallel lines, you're not going to have supplementary angles, consecutive interiors or congruent angles. Take note of that. Okay, and then there's this one. Again, all of that, if lines are parallel there. And again, when you're solving this, when you're solving that, the part of your answer is to write the statement. That is part of the solution. Okay, so I started with, let's see, these are the lines. You know that these two lines are parallel. And then you also know that these two lines are parallel. So that means you'll be able to either way use all those relationships of congruent and supplementary. Right? So if lines are parallel, then corresponding angles are congruent. So that means we can say that this 106 can also give you up there to use 106. Okay, and then to find Z, those are also corresponding. Right, and then to find X, I used consecutive interior angles are supplementary because I'm saying that we can use those two angles to add up to 180. Once I moved that 106 up there, what's another way to, like, you could have had a different reason here. Sometimes you might have a different reason that's also correct with these problems. What would be another way of knowing that that's 74? I used those two angles are supplementary. What's another way that you could have found if that's 74? Ryan, what kind of angles are these? Oh no, corresponding would be this one and that one. I want to know when they're supplementary and adjacent, what are they called? What are those two ones called? That's a linear pair. So another way to do that would be to say that linear pairs are supplementary. Okay, you might have a different reason than me, but as long as that makes sense with the diagram, then that's okay. All right, and then for Y, let's see, I'm using now that this angle being 74 makes that one 74. So I'm using the corresponding angles again, but you could also have used a linear pair. So 2y plus 106 equals 180. Okay, so you could just do 2y plus 106 equals 180. It'll give you the same thing. Obviously, if you subtract 106 on both sides, you'll get that 74. Questions on this one? And again, the statement of the theorem is part of your solution, part of your answer. So you need to make sure that you're writing that. And then the last one. What is that shape? You guys know what that is? It's a quadrilateral. It has two pairs of opposite sides that are parallel. That's a parallelogram. So not all quadrilaterals have any parallel sides, but not necessarily even two parallel sides. What is this shape? That's a trapezoid. A trapezoid has one pair of parallel and one pair that's not parallel. So it's a quadrilateral with only one pair of parallel, but what you've got there is a parallelogram. So on this one, you can use any two consecutive angles being supplementary. Okay, why did I make an equation? Again, let me get rid of that. Lines are parallel. Why did I start with an equation that was 11x plus 4 plus 5x equals 180? Why did I add those two instead of, for example, adding these two? Yeah, yeah. So it is possible to solve a problem where you have x's and y's mixed together. But remember, that's like a system of equations. You have to do substitution or elimination. It's a lot easier when you're able to combine x's together and combine y's together. Okay, so those two add up to 180. These two add up to 180. And then you can separate your x's and your y's. But it's the same reason for both of them. Right? Both of them are using the parallel lines make the consecutive interior angle supplementary. Okay, questions on that one? Again, super important that you're able to write those statements because that's part of your answer. Okay, all of those theorems. They could be, again, it could be one of the newer ones, or it could be linear pairs are supplementary or vertical angles are congruent. So you have, that's basically what you have to choose from. Okay, so you talking about this one? Uh-huh. Okay. All right. So first of all, these angles are not linear pairs. Remember that linear pairs have to be supplementary. So a linear pair, sorry, they have to be adjacent. So a linear pair would be like this one and this one. So those are consecutive interior. They're not a linear pair because they're not adjacent. And then alternate interior would be like if you use this one and that one. So because they're on the same side of the transversal, those are consecutive interior. This one? Yeah, I showed that. But that's okay, you can check it. Again, you want to make sure you're writing the statements. If lines are parallel, then alternate angles are congruent, or linear pairs supplementary, or vertical angles are congruent, whatever the reason is that makes your equation true. All right, okay. Go ahead and submit that again. Make a second submission to the same assignment. It was homework number 30. So now it's going to look like it's late because you're putting it in the second time after it's due, but that's okay. I'll make myself a note here and stability. Say again. That would be a good question. As soon as I get them graded, I gave honors quizzes the same time I gave you guys quizzes, and after I taught on Tuesday, I didn't do any work until Saturday, and I did a lot of work on Saturday and Sunday, but I haven't finished the grading. So I haven't even finished that honors quizzes that I gave prior to you guys, so I'm working on it. Okay, you're going to need lesson 3.5, which is in today's folder. So if you look at Wednesday, you'll see the lesson 3.5. Usually students kind of like this section because it's a lot of kind of like what you're used to of like normal math. finding angle measures and kind of looking at shapes, looking at triangles. It is only 45 degrees outside. Jeez. Max, come over here. Come over here and plug in. Do you have a charger? Oh, is she using your charger? Okay, so you need to plug in. All right. Colleen, do you need to borrow a charger? Are you good now? Okay. Just come over here and plug in, and you can sit in that chair. Use that desk right here. I mean, well, you can plug in there too, but there's a extension cord with a plug there, or there's a plug here, either on my desk or over there. Okay. This is something you probably already know. The angles in the angles in a triangle add to how much? 180. The angles in a triangle add up to 180 degrees. Okay, this is called the triangle angle sum theorem. The triangle angle sum theorem. So the statement of the theorem is that the angles in a triangle add to 180. That's a fancy way of saying that, triangle angle sum theorem. Okay, so on this problem, obviously we would be doing 38 plus 25 plus x equals 180. So what is that? 63 plus x is 180. So what would x be? What's the value of x? 117. Okay. Okay, and that's using the triangle angle sum theorem. I'm going to say that a few times to get that in your head. That's how I abbreviate theorem. You don't have to put the little line underneath there. Okay, but instead of writing out the word theorem, you can just do that. All right. For the second problem, one option is to add all the angles to 180. What is another option? What if you just look at those two angles? What do those two angles? What is their relationship? Jake, you looked at me. You didn't say anything. Okay, Diamond. They have to equal 90, right? So you kind of have two options on this one. You can either just do the normal, add the equation, add the angle measures up to 180, 3x minus 1, and 31 and 90 has to equal 180. Okay, or you can just say, we'll kind of take away that 90 from the 180, right? It's like sort of like, just think about taking away that 90 there and just say that we know that 3x plus 1 and 31 has to add up to 90. So that's actually a different theorem, but we can still call that triangle angle sum theorem. We'll talk about that in a few minutes. Oops, 3x minus 1. Let's copy that. Okay, so we have 3x. That's what plus 30 equals 90. So 3x is 60, and x would be 20. It didn't ask you to solve for angle measures here. It just said to find the value of x. So these two together would add to 90 because you already used 90 out of the 180. All right. In triangle DEF, so we don't know what the triangle looks like, but we do know it's some kind of triangle. 20, yep. In triangle DEF, measure of angle E is 3 times the measure of angle D. So I'm just going to call this X, and measure of E is 3 times that. So it's going to be what? 3x. Okay, measure of angle E is 3x. And then it says angle F is 9 less than the measure of angle E. Angle F is 9 less than the measure of angle E. 3x minus 9. So that angle measure is going to be 3x minus 9. Okay, then what? How? We need an equation, right? What's the equation? Equals what? 180. Okay, Sean, talk me through that.
Add 9 to the 180.
Okay. Add 9 on both sides.
And then combine all the add 3.
How many are there?
Yeah, 7.
Does that go in evenly? Okay, so 7 times 2 would be 14, and that would give you your remainder of 49. Does something go into 49? How many times? 7. So it actually does go in evenly. So x is 27, but then it did ask us to find the angle measures. So which angle is 27? Angle D. Okay, measure of angle E is 3 times that. So 27 times 3, 71, I think. I should have done it vertically instead. 27 times 3, 81. There we go. Okay, and then there's 2 different ways you can find angle F. What's one way you can find angle F? Yeah. Yeah, there's actually 3 ways. That was different than what I was thinking, but yeah. So since this was 3x and that's 81, this is just 9 less than that. So that's going to be 72. Or you can just plug your x in, find your answer that way. Or you can add those up to and subtract from 180, right? You know, it has to be the rest of 180. So when you do these problems, always do a quick check and make sure that it works out. Okay, so 27 and 81 and 72. That's 10, 180. Okay. All right, so that's the first idea. The first idea is triangle angle sum theorem. The angles in a triangle add up to 180 degrees. Always, always, always. No matter what kind of triangle, right triangles, acute triangles, obtuse triangles, equilateral triangles, isosceles triangles, scalene triangles, any triangle, the angles add to 180. Okay, the next idea is what's called the exterior angle theorem. So first of all, what is an exterior angle? In this picture, I've shown you an exterior angle. An exterior angle is an angle that where you start with a triangle and you're going to extend one side of the triangle. Okay, so take a side and stretch it out. If you use a current side of the triangle along with that extension, so here's our extended side, and then here's the other side that we're using, that creates this angle out here that's called an exterior angle. Okay, the definition of exterior angle is an angle that's formed by one side of a triangle and the extension of an adjacent side. Okay, yeah. These two together are going to be 180, right? Because they're what? They're a linear pair. An exterior angle forms a linear pair with one of the angles of the triangle. The angles inside still add to 180, and then angle 2 and 4 add to 180. Now, I could draw an exterior angle at any vertex. So if I wanted to draw an exterior angle over here, for example, I could stretch out that side and then use this side of the triangle. I'm going to call that angle 5. That's also an exterior angle. Okay, let me do the same thing and stretch out this way. So I'll try to make that a little straighter. Is there another exterior angle now? Is this one an exterior angle here? That one's vertical. Jake, why is it not exterior? Yeah, it's not adjacent to one of the angles of the triangle, right? It's vertical to an angle. It's not an exterior because it's not formed by just one side of the triangle and an extension of a side. Angle 6 would be, would be exterior. Yes. Yeah, you could still maybe know or be given or use that angle measure. That one is not an exterior angle though. So at every vertex, you're going to have two exterior angles. So I could do the same thing over here. I could stretch this side out and create another exterior angle here that would be congruent to 4, but this one over here would not be exterior because it's vertical to one of the angles inside the triangle. It's not adjacent to it. All right, so exterior angles are always formed by stretching out a side and using a current side of the triangle with an extension of an adjacent side. So the second term you need to know is remote interior angle. Okay, so what does remote mean? Like a remote island, remote control. Yeah, it's like by itself away from other things, right? Remote is like far away. Interior means what? Inside. So if you look at angle 4, there are two angles in the triangle that are remote interior. I'm going to draw another picture over here because I don't want you to get confused. There's a lot going on that picture. Let me draw another triangle and extension there. And I'll number them the same as up above. So this is 4. I have 1, okay, 1, 2, 3. Okay, so 4 is an exterior angle. If you use 4 as your exterior angle, there are two angles that are called remote interior compared to angle 4. Hi, Jerron. Those two angles, thank you, are remote interior to angle 4. Why does that make sense? Well, they're far away, right? They're not touching angle 4, but they're interior angles of the triangle. Angle 2 is an interior angle of a triangle, but it's not remote. It's just an interior that's adjacent. Right? So these two are called remote interior compared to angle 4. What's what? So remote interior means they're inside the triangle, but they're not touching the angle. They're far away. So it's the two that are not touching the angle. If I had, I'm going to copy this over again and make another picture. When I'm saying touching and I'm saying like right there, how that's adjacent, I'll just say adjacent instead of touching it. So let's say that I used a different extension. Let's say I stretched out this side instead and called that angle 6. I'll leave that. Oh, angle 5. What did I call it up there? Was that angle 6 up there? Okay, I'll call it angle 6. So if you ignore angle 4 there, if I use this as the exterior angle, Colleen, where would be the remote interior angles? 3 and 2. So, oops, those two are remote interior because they're inside the triangle, but they're not adjacent to angle 6. Okay, so you don't want to use the one that's right beside the angle. You want to use the other two that are across the triangle. So again, those would be remote interior, but it's kind of like a relative thing. Relative to angle 6, the remote interior would be angle 3 and angle 2. This is less than 3.5, John. Okay, so let's look at if you have actual numbers there. I'm thinking of actual numbers there. So tell me how to figure out, I want to know this exterior angle right there. I want to know that angle measure. Why? How do you know this one's 30? Okay, so 115 and 35 is going to add up to 150. And then subtract that from 180. It's 30. Okay, so that's that angle measure. So this angle measure should be 150 degrees because these guys are a linear pair. Okay, do you see a quicker way of getting that that's 150? So this is our exterior angle here, just like up above, right? That's our exterior angle. Do you see a faster way of getting 150 instead of having to subtract from 180 and then subtract from 180 again? Rating. Their remote interior. Okay, Jake, tell me why that makes sense. Yeah. Okay. So if we add up all the angles in a triangle, it adds up to how much? 180. So there's 180 here, right? And then where's the other 180? The linear pair, right? Diamond said a few minutes ago, she's like, okay, these two will be a linear pair. Yeah. So those two are 180. And then this is also 180. So that's kind of like the common thing there. When you take that out, the other two parts have to be the same. So the quick way to do a problem like that is to use, this is called the exterior angle theorem. It's always going to be like that. So this exterior angle is always the sum of the two. What do we call this? Remote interior. Drew, hi, you need to sit up, please. Braden. I mean, you can do it the way that Diamond initially told me right there, but it'll be quicker if you do it this way. And sometimes there's problems where you really don't want to do it the way that you just asked me, because sometimes there'll be expressions there. So if there are X's involved in the problem, it's going to be a lot easier to be dealing with those two adding up to the exterior rather than trying to figure out an expression for this other angle over here. Okay, so it's always going to be true that you can add up the interior angles to 180 and then subtract from that angle measure from 180 again, but it'll be quicker if we don't do all those steps. Okay, this is called the exterior angle theorem. Actually, I don't even care if you use triangle there. We're just going to call it exterior angle theorem. Yeah. Uh-huh. Yes. The exterior angle theorem says the measure of an exterior angle of a triangle, the measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. Okay, so again, an exterior angle is going to be formed, let me draw another triangle here. Okay, an exterior angle is formed by stretching out a side of the triangle. So if I extend that side, okay, I would get an angle out here. This is your exterior angle. And it's going to be the sum of the two angles that are not adjacent. So it's going to be the sum of that one and that one. Okay, so the exterior angle will be equal to the sum of the other two. It'll always look like that. It's always going to look like the two that are not touching it adds up to this exterior angle measure. Okay, so that means that for this problem, to find x, we could just use that idea, right? The exterior angle is 122. It's the sum of which two angles? The right angle and x. Those two are going to add up to give you 122. So x plus, and we know that's 90. X plus 90 is equal to 122. X is 32. Now on this problem, what Braden asked me a little bit ago was, well, can't you just go ahead and do the adding to 180 and subtract it? You could do that on this problem because you could figure out this angle measure, right? How would you find that angle measure? Yeah, subtract from 180, you find that linear pair, part of the linear pair, and then you could add them up to 180. You could do it that way, okay? But this is saying that the sum of the remote interior angles equals the exterior angle. And that's called the exterior angle theorem. So no, if it just says find the value of x, you're just writing equation solving it. But if I ask you what theorem you're using, it's the exterior angle theorem, or you could write the statement like that. So Braden, this is an example of kind of what you were asking me before. Yeah. So for this kind of problem, we don't want to have to mess around with trying to figure out an expression for that. We're going to go ahead and just make an equation there. Kendall, tell me what the equation should be for number 2. Which angle is the exterior angle? Okay, so then that's going to equal what? Added together. Okay, so make sure that you identify the exterior angle will always be bigger than either of the two remote interiors because it's the sum of them. So 6x minus 7 would equal 2x plus 103 minus x. All right, let's see. We have, let me go ahead and add the 7 over, and I'm also, oh, let me just do that. And this is 3x plus 110. So subtract, and we'll get 3x equals 110. Oops, sorry, not 3x, 1x. Just focus for a second. 5x equals 110. It doesn't have to divide evenly, but usually we do. And that's 22. Okay, so do not be trying to figure out this angle in here. When there's x's in the problem, you really want to be using the exterior angle theorem. Okay, the exterior angle is the sum of the two remote interiors. It's what? The exterior angle, this is the exterior angle theorem. Okay, a corollary. A corollary, the cleaning bell is going to ring in a minute, but we're going to keep going. A corollary is like a mini theorem. It's a theorem that follows easily from another theorem. So it's kind of less important. I mentioned this, we kind of talked through this a minute ago. In a right triangle, so here's a right triangle. In a right triangle, what is true about the measure of angle A and the measure of angle B? Jake? Okay, what's the word for that? They are complementary. They add up to 90. Okay. The acute angles, not the right angle, but the other two angles in a right triangle are complementary. So let me just move that up there. We'll show it on time. So the two angles that are not the 90-degree angle are going to be complementary because you're taking the 90 away from the 180, and the leftover will be 90. Okay, that's a corollary. Another corollary is in a right triangle, sorry, in a triangle, there can only be one right angle. Why is that? Yeah, you'd have two right angles. You already have 180. There wouldn't be a way to finish off a triangle that way, right? You have a 90, a 90, and a 0, and that doesn't make sense. So there can only be one right angle. What other kind of angle can there only be one of? Obtuse. There can only be one right angle or one obtuse angle in a triangle. So if you have an angle that's already over 90 degrees, then of course the other two can't be 90 or more because you're going to be over 180. So those are both corollaries of the triangle angle sum theorem. The acute angles of a right triangle are complementary, and there can be at most one right or one obtuse angle in a triangle. Okay, so last problem here. You're given a right triangle, so let's draw a right triangle here. I'm going to make sure you know it's a right triangle by putting the little right angle mark down there, perpendicular mark. The measure of one acute angle of a right triangle is 5 times the measure of the other acute angle. So if I call this one x, the other acute angle will be what? 5x. One of the acute angles is 5 times more than the other. Okay, find the measure of each acute angle. There's 2 ways you can do that. Derbla, can you give me one equation that would work? Five x plus, okay. That's one option. Or you can say when you add 5x and x, it's going to equal 90. So this is using the triangle angle sum theorem. This is using the corollary. So it's a little shorter, but either way will work, right? We know that these two have to be complementary. So that one and that one are complementary. So 6x equals 90. X would be 15. Now it said find the measure of each acute angle. One of the angles is 15 degrees. What's the other angle going to have to be? 75. And they have to be complementary, so they have to add to 90. Now, of course, you could do 90 plus 15 is 105, and then do 180 minus 105. But it's a lot easier to just say, well, those guys have to add to 90, so 90 minus 15 is 75. Okay, this is, either way works. This is the easier way. Doing this and doing this is going to be the easier way. The other way works, is just a little longer. All right. Because, oh, there's actually another way to get it too. I'm just doing 90 minus 15. If this angle is 15, this is the rest of the 90, so it's at 75. Or you can do 5 times 15, because it's 5x. You can also do 5 times 15. So the quiz is not till Friday, so you'll see me tomorrow, and you'll get a quiz review tomorrow. The homework that you're doing for tomorrow will be problems about this lesson, and then there's a couple of proofs.